Welcome to my Introduction to Chemistry course. Let's have fun learning a lot of chemistry this semester, and hopefully by the end of the semester you'll be able to appreciate how the chemical world works, and you'll have more understanding about how things works in the chemical eyes. So let's get started. But before we dive in, I would like to briefly talk about how you can best take advantage of these video lectures. These video lectures are set up in such a way so we almost always talk about some concepts or calculations first. Then we follow them through with some examples. So I strongly suggest before you move on to the answer portion, I hope you pause the video for a while and work on those real problems on your own for the best learning experience. So let's get started. For many of you, this might be the very first chemistry course, and some of you might be wondering, what is chemistry? So, what is chemistry? Chemistry actually is a science that is focused on matter. And it's focused on what matter does by studying the composition, the structure, which in turn determine matter's properties and change. So, in other words, for a chemist, the most important thing is to connect the microscopic world, to connect the small things like atoms and molecules to the matter's properties and changes they can undergo. So let's quickly follow up this chemistry concept by a problem. Let's look at that. So do you know what is chemistry? Let's look at choice A. It says chemistry is a mystical search for the meaning of life. This is more like a philosophy than chemistry. And for the second choice, it says chemistry is the science of what matter does. Exactly, because that's what chemistry is. So apparently B is the correct answer. So let's look at one real life chemistry example. So when you look at this picture, you might be wondering, what? This is chemistry? Yes, this is chemistry, because chemistry is the science about matter, and matter is everywhere, including what you're looking at, the pop soda. When you open the can, you hear the pop sound and you taste it. It's kind of sweet. You also noticed a lot of bubbles come out of the can. So what is this? When you look at this from the chemical world, you would notice one thing. The bubbles, actually, they are so-called carbon dioxide molecules. Oh, let's move back. They are carbon dioxide molecules. When you use the model to represent it, let me explain it a little bit. Okay, so in this model, carbon dioxide, CO2, carbon is represented in black, and oxygen, they are in red. So you have CO2 over here. And apparently in pop soda, you have water molecules, H2O, which is represented again in red. That's oxygen. You have two hydrogens surrounding the oxygen. So that's why you see H2O over here. Perfectly explained from the microscopic world by looking at the molecules CO2 and H2O. We have many more examples. For example, when you look at some of the daily usage of the chemicals you might see. So your pencil, the DNA that is included in you. So basically everything you see over here, they are so-called chemicals. So chemicals is actually the same as so-called matter, because matter is everything that you come in touch with, that the air you breathe, and anything that you might think of. Of course, we'll go into the details about what matter is later on. But for now, I would like to emphasize one thing. So many people have a very narrow view about chemicals and thinking the chemicals are dangerous, poisons, or pollutants and everything. And that's totally a misconception. Chemicals are anything that you could come in contact with. And it includes, for example, air, water, toothpaste, or anything. All right? So, let's quickly summarize what chemistry is. First, chemistry is the study of matter. And second, chemistry tries to connect the small world or microscopic world, or in another word, try to connect atoms and molecules with their corresponding properties and changes. Now, let's move on and talk about how chemists think. As a science, chemistry is done in such a way, and it's very methodical, and we call that method so-called a scientific method. So what are some of the key features of so-called a scientific method? The scientific method actually features observations, hypotheses, laws, theories. So let's go into the details. For example, first, what is observation? Observation actually is what you see. Observations involves measuring and observing some aspects of nature. Hypothesis actually tries to explain your observations or how things work. And what about laws? Laws, they are also observations, but it is the summarized results of a large number of observations. So what about the theories? The theories, they are so-called the models that explain. Again, I hope you notice the keyword for theory is also explain, because theories explain how something works. So, what is the difference between hypothesis? So, hypothesis and theories, both of them explain things, but hypothesis is more tentative interpretation, while theories are more established. What's the difference between an observation and a law? A law summarizes a lot of observations. A single observation could be your measurement, could be an experiment. But if you summarize everything that you observed and you put it together, that's a law. So let's go over the whole procedure about the so-called scientific method. In the scientific method, usually, but not always, you start with so-called observations. When you make a lot of observations and you summarize these observations, this is so-called a law. And the law has the predictive power, just like the theories. When you can predict something, and this actually reconfirms what your observation is. If you try to explain how a law works, you would have to formulate some explanation, and the tentative explanation, that's so-called hypothesis. But hypothesis can be wrong or correct. So how do you prove or disprove this? You design some experiments. So what is experiment? Apparent experiments are the purposefully designed procedure to prove or disprove hypothesis, or you can prove or disprove the law. Do remember, the laws and hypothesis, both of them are falsifiable. So if the hypotheses are not confirmed, what should we do? You should revise the hypothesis and test through further experiments, Although we say one experiment can't disprove a law or hypothesis, but we got to be very careful. More experiments are usually required. Many of you probably heard about the law of conservation of mass, which was done by a French chemist, Antoine Lavoisier. Basically, what this law tells you is mass cannot be destroyed or created. A good example of theory would be Dalton's atomic theory, which we will go into details in the next chapter. So Dalton's atomic theory tells you everything is made of atoms, the indestructible, smallest unit in the chemical reaction. Again, this is formulated by John Dalton, an English chemist. So by now, we have learned some key features of the scientific method. We know what a law is, what a single observation is, what a hypothesis means, and what is the so-called theory. So let's follow this up with one question. So this question asks you, which of the following statement best describes the law of conservation of mass? As we explained briefly, apparently D is the correct answer, because it says mass is neither created nor destroyed in the chemical reaction. So D is the correct answer. I'm going to emphasize one thing over here. Back in Lavoisier's time, there's no so-called nuclear reactions. So they did not say in the chemical reaction, but we add this in to make it more correct. So that's why you see it cannot be created or destroyed in a chemical reaction. Let's look at the next question. Classify each statement as an observation, a law, or a theory. Please note this is not a multiple choice question. Yeah, it looks like one, but it's not. So let's look at statement A. When the matter is burned in a closed container, the mass of the container and its contents does not change. Apparently, this is what you see, which means this is an observation. So that's an observation. Let's look at the second statement. Matter is made of atoms. This one is kind of confusing because when you look at that, yeah, that's a fact. And it is true. Matter is made of atoms. So some students say, oh yeah, that's an observation. This is not directly observed though. This is what we use to explain what we have observed. So actually, this is a part of the Dalton's atomic theory. So this is actually a theory. So statement B is a theory. What about statement C? Matter is conserved in chemical reaction, as we just learned. This is actually part of the law of conservation of mass. This is summarized observation, or in another word, this is a law. Statement D is very similar to statement A. Apparently, you observe something that's happening, and when you measure the mass before and after wood is burned, the mass does not change, so that's an observation. All right, let's look at one more example. So theories are validated by what? We looked through that picture, so we do know it's validated by purposefully designed procedure, which are called experiments. We actually have one more, a couple more. A brief statement that summarizes past observations and predict future ones is called, that's called what? That's called a scientific law. Because this brief statement is actually so-called a summarized statement. Look at the keyword, it summarizes past observations. So summarized observations are called scientific law. Which of the following scientists stated and studied the law of conservation of mass? Apparently, that's Lavoisier. Which scientist proposed that all matter was composed of small, indestructible particles called atoms? That's John Dalton, the English chemist, John Dalton. This is part of Dalton's atomic theory. Which of the following is an example of a scientific theory? Let's look at A. The addition of battery acid to sugar results in the formation of a black substance. This is what we observe because that's what we see with our very eyes. That's an observation, not a theory. Second, gases consist of molecules in constant random motion. Again, this statement is correct, but is this an observation or is it a theory? It turns out this is a theory. This is part of the so-called kinetic molecular theory, which is used to explain some of the behaviors of gas. So B is the correct answer. Choices C and D, both of them are observations. The correct answer, again, that's B. Look at the next example. Which of the following is an example of an observation? A, you look at energy may be converted from one form to another, but the total quantity of energy remains constant. Apparently, that's a brief statement that summarizes everything. So this turns out to be the law of conservation of energy. As we just explained, statement B is a theory. C, the burning of wood results in flame, heat, smoke, and ash. That's exactly what you see. So this is an observation. Look at another example. Which of the following is a scientific law? So as we explained, A actually turns out to be the law of conservation of energy. This is the summary of all the observations you have made. Let's look at one more example, which is the last one. Which of the following statement is false? Look at A. The scientific method is a way of learning that uses observations and experimentation. That's correct. Observations and experimentations are really important. Usually you start with the observation in the scientific method, but you don't have to start there always though. So through experimentation, you can prove or disprove your hypothesis, or if you can find one example that disproves your law or hypothesis must be revised or sometimes be totally thrown away. Look at B. An observation is an educated guess. An educated guess is actually a hypothesis. An observation is what you see. So B is the correct answer. All right, so let's summarize what we have talked about for this section. First, we have already learned one important thing. What is chemistry? Chemistry is the study of matter. Second, what is the scientific method? The scientific method features several things, including the observation, the hypothesis, the law, and the theory. All right? Have a good day.